Monday Trivandrum office.
Okay.
Yeah. So you are still with IRTC?
Now I am in IRTC.
Okay.
And what about you are still the consultant for NCESS, isn't it?
Yeah, that's right. Correct. Okay.
Last time also I attended your program conducted by Professor Govalish. I was there.
Okay.
For a 20 minutes or so. Then I quit it.
Oh, I see. In fact, I have a small urgent things in Kannur. That is why I came. So, ഇവിടെ പോയിട്ടുണ്ടാ സഹൃദയ കോളേജിൽ പോയിട്ട്
ഞാൻ പോയിട്ടുണ്ട് ഡേവിസ് എന്നെ വിളിച്ചിട്ടുണ്ട്
വോയിസ് പ്രശ്നമുണ്ടാ വോയിസ് പ്രശ്നമുണ്ടാ
ഇറ്റ്സ് ഓഡിബിൾ ഇല്ല കുഴപ്പമില്ല കേൾക്കാം ഓഡിബിൾ ആൻഡ് ക്ലിയർ
ഇത് അല്ല സഹൃദയയിൽ പോയിട്ടുണ്ടോ ഇതിനു മുമ്പ് എന്താ ഈ കോവിഡിന് മുമ്പ് എന്നോട് പറഞ്ഞായിരുന്നു പക്ഷെ നമുക്ക് അപ്പോഴത്തേക്ക് കോവിഡ് വന്ന് പോരത്തില്ല
ഇനിയിപ്പോ യാത്ര ഒരു വലിയ ബുദ്ധിമുട്ടാണ് ഓരോ സ്ഥലങ്ങളിൽ
I think it will resume. I have traveled many times to Trivandrum. By own car, by flight, or even by train.
I see. Okay. You can take flight from Kannur to Trivandrum, isn't it?
Yeah, that is it.
That is the way.
Yeah. So it takes hardly 1 hour.
1 hour. Okay. 40 minutes. This is.
Yeah, because minimum it requires to take off and landing, it takes 20 minutes. So, Srinivar is in
I am sitting at
Mundur or
Irinjalakuda.
Oh, I see. So you travel or
I used to come here 2 or 3 days, 3 days a week. That's all.
Oh, I see. Okay. So Shashidharan Pulla comes now.
Now he is it's a senior consultant, that's all. Senior faculty member.
Okay.
They are all the main people.
IRTC was one of the
it was under your KSST.
So I visited 3 times IRTC.
But in solid waste management and watershed, we are doing very good.
That is
fundamental, grassroots level we are doing something.
Correct.
Now, after reaching here, we have organized a geoinformatics center. Your favorite.
Okay.
Your favorite.
No, I was telling, in fact, Shashidharan Pillai, that you have potential. Why don't you start? So at that time itself, I told Shashidharan Pillai, if you require any help, just tell me, because it is can definitely cater to many of the special applications that you require.
Okay. Now we have got a very good laboratory and very efficient project scientist here. Very good. Yeah, that is the strength of the lab. Very good.
So
they are very sincere and therefore I think we can do something in future.
Already acquired all softwares like you have for image processing.
The thing is that we have just started. We have to procure more softwares and all, and I think KSST can help us. Sometimes we have given a project.
Okay.
In the non-plan fund.
Okay.
Plan fund also we have given something requested KSST. I don't know whether if it happens.
I think Davis is getting.
No, I have got a program after this, so I will quit from the program. Okay. After just starting. Okay.
Good morning, Ramachandran. മ്യൂട്ടാണ് ഓഫ് ചെയ്ത്.
Good morning, Dr. Srikumar.
Yes, good morning.
Welcome, Dr. K Ramachandran.
Yeah, thank you.
Okay, we can start.
Sure.
Okay,
Yes.
one moment. Okay.
A very warm good morning to all. Hope I am audible to everyone.
Yes.
Yes,
Okay.
yes, please.
Welcome to Environ 2020 National Online Lecture Series Day 3, which is hosted by Department of Geology, Sahridaya College of Advanced Studies in association with Center for Environment and Development, Trivandrum. Thank you all for joining with us for the third section of this lecture series. It is my pleasure to invite Professor Dr. S. Srikumar, Director, IRDC, Palakkad, for the felicitation.
Okay, all the principal and the head of the Department of Geology, Sahridaya College, Professor Davis, and distinguished resource person here, Dr. Ramachandran, K Ramachandran, and other faculty, and also dear students. And you see that our guest today, Dr. K Ramachandran, he was serving in National Center for Earth Science Studies as scientist for last several years. And I think he joined in 1984, I think. 83 or 84?
83.
83, yes, 83. And you see that he's still working as a consultant in National Center for Earth Science Studies. And you see that he has handled different portfolios in National Center for Earth Science Studies as the head of the Geoinformatics lab. I remember him when the Geoinformatics started its route in Kerala. So he was heading the Geoinformatics laboratory. And he has done excellent work in, he has used geospatial tools, technologies in solving different earth science and geo-environmental issues. And also, I know that he's very much involved in coastal regulation zone and its activities, and also the official proceedings in the coastal regulation zones and everything. And you see that he has done a very good job in marine research, marine science research, and he has very good deep knowledge in earth science, and he has published several papers in national and international journals. And also very, very important thing is that IRTC is actually a grandinate institute of KSST, Kerala State Council for Science and Technology, and he was the member secretary for a term in the KSST. And also, so he has got both administrative as well as scientific skill in managing things, and I think he's a right person. And I know he's very, he shows very much interest in linking with the colleges, faculty, and universities. That's a very good response from the scientists, like great scientists like K Ramachandran. And you see that this topic, I think he's talking on landslides and slope processes like that. And we are very, you all, the students are all, and also the faculty may be benefited by his very useful talk on this particular topic. And he may be able to share a very good or the evolved evolution in the hazard zonation mapping and all, and the models for the slope movement. And I welcome you, sir, for the wonderful session going to be here in this. I welcome Dr. K Ramachandran.
Thank you very much, Srikumar. In fact, I think you know each other for more than 37 years. So, yeah. Thank you for the nice words that you know. In fact, you are the person who's initiated in Kerala, the research on landslides. Am I right, Kumar?
Yeah. I started the PhD. We were talking about that one when you were in SES.
Okay, so we had a very good interaction even from those days. So thank you for nice words. I know I have another program, so I'm not taking much of your time. So I will get into my presentation. Dr. Davis, can I get into the presentation?
Just wait. Wait a few moments, okay?
Pardon?
Just a few moments after.
Now,
Yeah,
we,
sure.
now we'll move on to our third lecture, Environmental Degradation Leading to Landslides in Western Ghats by Dr. K Ramachandran, retired scientist and consultant, National Center for Earth Science Studies, Trivandrum. A reminder to everyone, please turn off your cameras and microphones for the smooth conduct of the session. And if you have any doubts during the session, type your questions in the chat box. Also, attendance is mandatory for receiving the e-certificate. For that, you have to fill out feedback forms, which will be shared at the end of the session. Now, I invite Mrs. Ashba Binoy, Faculty of Department of Geology, to introduce our resource person.
Do you require a big introduction now? Srikumar has already done a great job. Okay, thank you. No issue.
Good morning, Manandra. Am I audible to everyone?
Yeah.
I would like to introduce today's presenter, Dr. K Ramachandran, retired scientist and consultant, National Center for Science and Studies, Trivandrum. Major highlights of his career is secured doctorate in marine sciences from Cochin University and has joined as a scientist at an age of 22. He has attended many oceanographic cruises in Indian Ocean. In research and development and scientific management career with government, private and abroad, and also have 4 years full-time administrative services in Kerala State Council for Science and Technology and Environment. In addition, he has carried out several consulting work on CRZ mapping. His major publications consist of 29 papers presented in conferences, 31 papers in national and international journals, and also a co-author in 3 books. Once again, welcome you, sir, to this presentation. Thank you, sir.
Thank you very much. So, can I go ahead, Davis, with my presentation?
Okay, you can start, sir. Okay, we can start.
Yeah, sure. ഞാനൊരു പ്രസന്റേഷനിലാണ് I will call you. Yeah, can you see now?
Yes, sir, your presentation is visible.
Okay. Okay. Yeah. So, there is a small change in the title. I'll be talking on environmental degradation and landslides in Western Ghats. It was actually, the title was environmental degradation leading to landslides. I have made an amendment because actually the environmental degradation accelerates the process of landslides. Will not be the sole cause for the landslide. So I thought scientifically it is prudent to put environmental degradation and landslides in Western Ghats. Okay, so I am at the onset. Let me thank Dr. Davis. I have a very long association with Dr. Davis. I know him during his studentship onwards. So thank you for giving this opportunity, and I should also thank Srikumar, who has actually into this field, initiated into this field in a research mode as early as 1984-85 in Kerala. Okay, so when we talk about the environment, let us understand. Since the students are involved, let me go to little elementary level, wherein I would like to tell what is that we talk about environment? What is the environment? So anything that surrounds us, anything that surrounds us, and with which we interact. So this is very important. That anything that surrounds us, with which we interact, whether it is living things, non-living things, our built environment, or even social relationships and the institutions around us. Okay, so the living things like animals, plants, forests, fungi, etc. The non-living things like continents, oceans, clouds, soil, rocks, and the built environments like buildings, human created living sectors, parks, anything around us. So the scope of environment is all encompassing. Rather, it encompasses the atmosphere, which is a virtual ocean of air, the hydrosphere, the surface of earth that is filled with water, which is actually having a wide coverage over the earth's surface, the lithosphere, the outer shell of the earth, which is composed of um, in fact, which is composed of crust and the rigid outermost mantle, as well as the biosphere, the place where the entire animal and plant kingdom lives on, exists. Okay. So, what when we talk about environmental degradation, what we really mean? So, environmental degradation is actually natural resource depletion. It could be because the degradation could be the result of the various social activities, the economic activities, the technological activities, and the institutional activities. So, all because of this, the natural resource get depleted, and it is the natural resources like water, air, soil, and it also impacts the wildlife, plants, animals, microorganisms, etc., that we see on the surface of the earth, as well as deep into the oceans. So, how does the environmental degradation happens? When you study geology, you have seen that this earth has evolved over 4.6 billion years to reach the present state of uh, affairs. So, but apart from the natural changes that is happening on the surface of the earth, there is also an human-induced factor. This human-induced factor are in multitudes like urbanization, population explosion, intensification of agriculture, increase in energy use, increase in transportation, etc. So generally, I just want to tell you that generally the environmental degradation refers to mostly the anthropic influences or the influences due to the intervention of man. Okay, so so you know the types of degradation, environmental degradation, is in terms of deforestation, desertification, extinction of certain living things, erosion in terms of the land erosion, mass wasting, the emissions causing pollution in the atmosphere, and so on and so forth. So when we talk about the landslide, it is I mean mostly about the land degradation. Okay, the land degradation is one part of the environmental degradation, which get accelerated due to again human-induced processes. Okay, so the value of the biophysical environment gets affected by a combination of human-induced process acting upon the land. So it is perceived as any change or disturbance to the land to be deleterious or undesirable, which is not actually healthy for the land, water, and air, and the sustenance of the living beings, including the human being. The the land degradation is the most important environmental problem currently challenging sustainable development in many parts of the world. So in the sustainable development goal, actually, this is one of the very important things, and that is why Government of India, through the Space Application Center Ahmedabad, has taken up a very challenging job to make a very detailed map on the land degradation and desertification aspect in India. Okay, so the problem is most acute where the environment is intrinsically vulnerable. So what does it mean? Means that where there is a delicate balance between the nature and the land. That because of the human-induced activities, it gets vulnerable to be hazardous, causing any kind of disaster future. Okay. So you take the example of one of the land degradation example is the soil degradation itself. You can see in this map which is published by UNEP, the UN Environmental Program, it has portrayed spatially that what is the sort of soil degradation happening around the globe. So you can see the very degraded soil category is pervasive in India also. You can see that in India also, the area that is getting affected because of the soil degradation is enormous. Okay, so it is almost along the west coast and the interior compared to the east coast, where we have stable soil. Okay, so so the causes of land degradation, I don't have to completely read out this. There are many things like clear cutting and deforestation, agricultural depletion of soil nutrients, poor farming practices. It includes also even the monoculture practices that we follow today. For example, in many areas, because of the socio-economic importance and the market interest, we have started diverting our energies to monoculture practices, like rubber, for example. So we have occupied the slopes and the disturbed surfaces, many areas for the monoculture practice of rubber cultivation. So similarly, there are many other monoculture practices that is there in the Western Ghats. So and inappropriate irrigation and overcasting, quarrying of sand, ore, minerals. Vehicle off-roading may not be very important, but still it is important because we started cruising our vehicles through any area because we have vehicles like nowadays we have the JCB and things like that which are used for cutting the roads and things like that. So even without road, you can take the vehicles. That is what is by off-roading of vehicles, which disturbs the land, the surface, terrain. Increase in field size due to economies of scale, reducing shelter of wildlife, and all these things are causes for concern. So if you take the Western Ghats region, it is spread over something like 160 kilometer length, starting from Kanyakumari to River Tapti in Maharashtra. So very enormous, mountainous region, one of the very important mountainous region in the world itself. So which covers something like 1.6 lakh square kilometers. So you just imagine. See, 1.66 lakh square kilometers, approximately, if I tell it is It is 4.5 times of Kerala. Okay, the area of Kerala. So it is something like that. So, and when you take these the Western Ghats as such, it covers Gujarat, Maharashtra, Goa, Karnataka, Kerala, and part of Tamil Nadu. So, and we know the formation of Western Ghat is, as geologists, we know. I'm sorry that it's Gondwana breakup is around 150 million years, not actually 1,500 is in Precambrian. So it is actually the late Jurassic period that we had in Triassic. We had the late Jurassic breakup of Gondwana land, which actually caused the upwarping of the Western Ghats as well. So it starts near the border of Gujarat and ending at the southern tip of India at Kanyakumari. It includes very, very important mountainous region like Sahyadri, what we call Nilgiri, Anamalai mountain ranges, and also it includes something like 34 peaks. Okay, so Anamudi is one of the highest peaks in that. Okay, so you can see in Kerala, if you take Kerala, this is a left side you see a digital elevation model. It gives the height of the terrains starting from the coast to the to the uh, to the coastal land, to the midland, to the highland, and crossing over 2,000 kilometers, 2,000 meters, 2 kilometers of height. Okay, so these are very, 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 very important maps when we talk about the landslide, because landslide is basically a slope process. Slope is mainly because of the terrainous nature of the land. Okay, so this is very important. Okay, you can see the high terrainous region uh, in say Wayanad and some Malappuram, Idiki, very, very, very highly elevated regions. Here, just to show how environmental degradation has taken place, I have also, this is actually taken, the deforestation map is taken from actually publication from Srikumar Chadopadhyay. So you can see that there are deforested areas. This color you can see, these are the deforested areas. Huge areas have been deforested. Even in the forest, the natural forest that we have today, see, we have 29.1% area being covered under the according to records. But the natural forest is actually very little. So it has undergone a transformation with time. So now we will come to the landslides. Because when you understand landslides, you will also understand the land degradation which I was talking about, because landslides are natural as well as man-made phenomena. So it's nothing but mass of earth or rock or debris that down. So this is basically a slope process, a process that is happening along the slope. Okay, so that is why we have a district Alapi where we don't find any landslides, but most of other districts we have. Okay, so the term landslide describes a variety of process that result in the downward and outward movement of slope forming materials, including rock, soil, artificial fill, or a combination of. For the benefit of the students, I have given this definition, but you simply understand that it is actually a gravity-induced phenomenon along the slopes, steeply sloping surface. Okay, it can be depending on the type of material and the nature of slide. It is classified in different ways. Okay, so some of the most damaging landslides are triggered by water, typically intense short-term rainfall or long-term saturation of the soil. So these two things are very important. Okay, So you have quasi-static components or factors that triggers the landslide. So that are vulnerable to landslides. So what are those things? I will come to that. The static, but the most dynamic factor that triggers, at least along the Western Ghats, is mostly by water. That is from the very intense rainfall that is being received during the southwest monsoon period along the southwest coast of India. We have long-term saturation of slopes. See, monsoon is from June to September. Okay, sometimes it also extends to October, but mostly it is June, July, a bi-monthly spell, and August, September bi-monthly. So these 4 months are the typical period during which we receive southwest monsoon. But the returning monsoon, which is otherwise known as the northeast monsoon, is after October. Okay, so October and November we receive. So both natural and human activities can saturate hills. So the already vulnerable areas, if there are some human-induced factors that accelerates, that actually superposes the vulnerability of that hillside to slide. So earthquakes and volcanic eruption also can damage landslides. You know, any vibration to the land. Earthquake is like that. Volcanic eruption is like that. So the vibration that is due to the earthquakes, the ground acceleration due to the earthquakes and volcanic eruption also, accelerates the process or the triggers the process of landslides. Apart from the rainfall induced saturation of the slope and debris flow. So you know a typical graphic illustration of a landslide. There are many terminologies that we use. We have a crowd. Okay, so you for the students. Okay, we have a crowd. So from the crowd, slowly a scarp develops. Track will be developed initially, and from there it starts sliding, making a main scarp. The head will start slowly getting through the rupture, flowing down along the slope. Okay, so you have a head here. Okay, you have a head. So this is actually the surface of rupture. The surface of rupture, in most of the cases, what happens is that the surface of rupture can be an interface between a hard surface and a soft surface, or a hard rock. But okay, so this could be the soil profile developed out of hard. Okay, can be the lateritized soil or the soil that is derived from the latent process of the bedrock. So you have a main scarp, you have the main scarp, you have the transverse scarps. Okay, you have the transverse ridges. You know, you can see the ridges. If you imagine three-dimensionally, you can see there are certain ridges transverse along the flow of the debris. Okay, you have the radial cracks. Here you have seen the traverse cracks, but you have the radial cracks. You have the toe of surface rupture. Okay, toe of the surface rupture. From it, it slowly starts spreading out. Okay, so there will be a surface of separation from the surface of rupture. Okay, then you have a foot. You can see typically it appears like a foot. Okay, toe, like what you have your toe on your foot. So you have the toe. These are the terminologies you can relate. Okay, there's a crown, and the crown cracks are developed. Then it develops into main scarp. Then the head develops down sliding down along the surface of rupture, and then, hope I am audible, isn't it? Hope I am audible.
Yes, sir, you are audible.
Yeah. Okay. Okay. Is it clear?
Yes, sir, you can
The-
proceed.
yeah. Okay. So these are the different terminologies that is connected to a landslide. Okay. Irrespective of what type of landslides, the type of landslide, we are coming to the associated landslides. So depending on the velocity of landslide, it is classified into extremely rapid. The velocity in terms of millimeter movement of millimeter per second is given. Okay, so per second something like something like 5,000 millimeters. 5,000 millimeters is nothing but 5 meters per second. Such a rapid flow. Okay, 5 meters per second. So you have also very slow, extremely slow. Hello. Yeah. Extremely slow landslides, like very slow, less than even a centimeter. So they are actually not perceivable with the naked eye, but as we see from year to year, we see that slowly the tree which is erect slowly getting sloped to one direction, by which you understand that there is some slope process that is going on. Okay, so then you have classification of slides based on bedrock, based on the type of movement, bedrock, and the type of materials that is involved in it. This is based on the once the 1978 classification. Okay, so this is still followed in many uh, books. So that is why I have put it as for academic interest. So you can see that the falls can be either a rock fall, debris fall, or earth fall. The topples can be rock topple. We'll come to this. What's the topple? What's the fall? We'll come to that. Debris topple, earth topple, rotational, translational, rock slide, debris slide, earth slide, lateral spreads, rock spread, debris spread, earth spread, and flows, rock flow, debris flow, and earth flow. And combination of, when it happens in nature, we cannot tell that it should be only fall, it should be only translation, it should be only flow. It can be a combination of these. So, these are the kind of classifications that we have. We have the rotational slides. That is what we have seen. The scar, developed scar of this separation is rotational. So it along the slope, the surface rupture is far concavely upward. The slide movement is roughly rotational about an axis that is parallel to the ground. Okay. So whereas in the case of translation, it just slides out. The translation slide is depending on the type of material and the type of triggering factor, it just slides over. Okay. So here also we have to see the fact that the underground material uh, above which the soft surface rust matters. The nature of that, the orientation of that matters. So in the case of block slides, it is actually, majority of the cases it's a rock fall or a tumble where you have the surface of rupture because of the gravity. Everything is because of the gravity. Because of the gravity, totally it becomes unstable and starts falling. So you have rock falls. Rock falls are abrupt movements of mass of geological material. Okay, you can see this. See, very very steeply sloping. For example, you have I don't know whether you have any time visited our Vakala cliff, the coastal cliff, the steep picking up to the top, and because of the unstable slope, when the material down here gets eroded due to rain or any other activity, slowly the overlying burden will come down. So that is how the rock fall happens. The topple is also of very similar nature, that because of the uh, gravity or due to the mechanical activity, as well as due to the gushing out of water or the interstitial water or any spring happening there, it can push out the rock, distinguished by the forward rotation of a unit or units about some pivotal point under the actions of gravity. So you have the in Kerala, mostly we see the debris flow. Debris flow is a form of rapid mass flow in which a combination of loose soil, rock, organic matter, air, and water mobilizes as a slurry that flows down the slope. But majority of the landslides that has happened, in fact, in the Western Ghats of western slope of Western Ghats, that is the Kerala part of the southwestern Western Ghats, is debris flow. Okay, so in some cases we also have seen debris avalanche. It's a variety of very rare. See, avalanche normally we see in places like Himalaya. So that is a very distinguishable, characteristic of Himalayan landscape. So there's no avalanche happens. Okay, so earth flows have a characteristic hourglass shape. You see, this is the earth hourglass. You know that earlier time we used the hourglass for finding the timing. Okay, so it is almost in that kind of a shape. Okay, so you have earth flows against the slope. The material gets liquefied and bringing down along a weaker trunk, and down slope spreads. Okay, so that is how a typical earth flow or mud flow is an earth flow which is actually involved with more than 50% of sand, silt, and clay-sized particles. So that is what we call it as mud. Okay. So, and creep. Creep is imperceptibly slow. That is what, in terms of the speed with which landslide happens, that I told that the lowest this one is in terms of millimeter or even centimeter per, which we cannot perceive with our naked eye. Okay, slowly moving, very, very slowly. It is not perceptible to our naked eye. It could be perceptible only if you see that there are tree trunks which are actually sloping in one direction. You can see sloping in one direction, and slowly the slope of the tree trunk increases. Or you have a fence. You have a fence constructed. Fence slowly bends, or the retaining wall bends, or you can see the electric lines with the tilted poles. Okay, so these are all actually the indications. You can see the compound wall. It's not stable. The retaining walls, the fences that we construct, they all get slowly to an angular level, or tilting happens to them, and ultimately it falls. So there also the main thing is because of the slow creep of the fluidized material or along a gently sloping surface. So there are, similarly we have the lateral spreads. Lateral spreads, you can see lateral spreads, slowly it spreads even without much of slope. Along a small gentle slope, the material start moving away. Material start moving away from a particular point. So the what thematic causes of landslides, the geological causes, geomorphological causes than the human causes. I think you can refer to any standard textbook, you will get all these things. So I don't want to go into the details of this because we have very limited time. Okay, so so three important triggering mechanisms for landslides are water, seismicity, and volcanism. Or water can be in the form of even rainfall, snow melt, groundwater, the springs, change in the water level due to the flood and things like that, or the influence of the canals, depth dams, etc. So all these things can cause as a triggering factor for landslides. Majority of the cases, majority of the area around the globe, the main factor that causes landslides. There are many factors involved in landslides, but which initiates the landslides, triggers the landslides, is mainly water, which is followed by seismicity. So seismicity, mountain areas, Himalayan regions, for example. Himalayan regions are vulnerable to seismicity. So those areas which are having acceleration generated due to seismic activity can cause landslides. Okay, so the occurrence of landslides in steep landslide-prone areas gets a fillip, gets an additional forcing through the ground acceleration generated to the earthquakes or the seismic activity. So the ground shaking is one of the causes in some of the areas. Even Japanese coast, we have this kind of issue that seismicity caused landslides are plenty in those areas. So island areas. So volcanic activity, landslides due to volcanic activity are some of the most devastating type. Okay, so volcanic lava will melt snow at a rapid rate, causing deluge of rock, soil. When the gushing happens for the snow, it also takes away along the steep all the materials that is available by making it devastating along the path of its course. So these are, you can see that where landslides occurrence, the number of landslides events. You can see the red area, entire India falls under the red area where we have 600, more than 600 landslides in a year. Okay, so this is taken from Froud and Petley 2018, and we have the reported fatalities around the world from Fishbomb et al. In 2015. So you can see that the Western Ghats is one of the mostly affected region where we have a lot of fatalities which involved with 11 to 25 deaths. Okay, so this is really a worrying thing. And you see the Western Ghats and the NDMA, National Disaster Management Authority guidelines for mapping, how to map the geoenvironmental parameters for slope instability or otherwise to understand the sonation of landslide hazard. So these are some of the factors which they have listed out: lithology, structure, slope morphometry, relative relief, land cover, land use, hydrological conditions, slope erosion, rainfall, landslide inventory, seismicity, geotechnical properties of materials, etc., etc. So you can see that you can see that the landslide hazard sonation maps are prepared in different scalability. You have the large, you see, small scale maps which are prepared in greater than 1:1 million. We have medium sort of thing. 1:1 lakh to 1:25,000. So this is actually to have an estimate of what are the areas that are prone to landslide. Okay, so when we talk about hazard, what is a hazard actually? So we should distinguish what is an hazard, what is a disaster, what is called vulnerability. All these terminologies are very, very important. Okay, when we talk about landslides. So see, yeah. So the potential source of hazard, potential source of hazard is it can be assessed from this one. Okay. So you can see the potentiality to harm can be termed as hazard in normal case, whereas the vulnerability refers to the inability to withstand hostile elements. So the one, so when you tell that this slope is vulnerable, what that means is that that slope may be unstable to withstand when a triggering mechanism acts upon. Okay, so a disaster is what? A disaster is something where serious disruption of life happens, causing indispensable, uh, human loss as well as property loss, whereby it suffers the economy, environment, and human life, etc., etc. Okay, so the risk involved in all this, the possibility of loss can be assessed, uh, based on these parameters. So geoscientists can help by mapping such hazardous zones. So that is what we were doing. So there are certain guidelines in mind. If you take this map, this is the map which we have prepared, wherein you can see the landslides that has happened till 2009. Till 2009, what are the locations where we had fatal landslides? Landslides that is causing death of people. Okay. So you can see on the background the hazard zonation map. The hazard zonation map, wherein the red color is nothing but the high hazard zone area. The medium hazard zone area is green, and the blue areas are low hazard zone. You can see that coastal area doesn't have any hazard possibility. Okay, so similarly, the landslide inventory map 1956 to 2016 prepared by GSI. You can see the distribution of landslides. Why not area where we were having recurring landslides. So we also have places like Malappuram, and we also have in Trivandrum we had, okay, in Retd. Okay? So these are the parameters which we normally use for under the BIS Indian standards, as well as the weightages and ranking that we have given for preparation. B means National Center for Assessment as given for preparation of hazard zonation. So you can see the slope is given, very important in our case. Geology, yes, very important. What is the kind of rock material available? Structure also takes an important structurally, the relative relief, land use, hydrological condition. See, these are some of the hazard zonation distribution in the different districts. You can see all districts are covered except Alapi doesn't. Okay, so but mostly you can see the study reveals 1,840 square kilometers, or 4.71% of the state is under high, and 3,759 square kilometers, or 9.77% under low hazard category. Devikulam, Vaitiri, Nilambur, Mannarkad, Rani are the most landslide prone taluks in the state. See, any location which has got a slope, if the overlying burden material is very thin or very loose, it can be soaked due to continuous rainfall and taken down the slope during a very torrential rainfall. That is what, in majority of the area, causes the landslides. So anyway, I am not going to the geospatial techniques because of the time constraint wherein we go for the mapping. You can see the landslide inventories that is prepared using the Sentinel-2 satellite data. You can see plenty. This is the 2018 episode that has happened in Wayanad, Kurchimala, many places. Sorry, Wayanad is this area. Then we also have in Kozhikode, okay, Erichola, Kozhikode, okay. So many places you can see the debris flow. It's visible even from the satellite images. Wow, how it is visible? Because this is actually the vegetated. The red zone is actually the vegetated, strongly vegetated areas along the hillocks, which is being cut across by the debris flow. Once vegetation start growing on this debris, this will not be visible even in the satellite. So this is very visible. Why we have used the Sentinel-2A is because the normal satellite for the optical remote sensing cannot detect during the cloudy season. So cloud penetrating microwave satellite sensor only can map during cloudy period such land features. Okay, so these are some of the things which we have automatically generated from the field using our field application software. Okay, so you can also, I don't want to get into the details of this. This is comparing what kind of data sets that we should use for mapping precisely the slope aspects of any area. So this is actually you see the huge landslides in Kodagu that happened 2 years back. You can see very huge landslide. We have also mapped Kodagu. We have mapped Kodagu for land susceptibility. We found that you can see the run areas which are having high susceptibility. The classification is given here. Okay, so we have used two different methods. In both methods, you can see that there are majority of the area here which are susceptible to landslide. This is where we also happen to see a very serious landslide in 2008, Avalapara landslide. So this is how we prepare the landslide parameters. You see, this is actually the slope that we have generated using different kinds of satellite data. Okay, different types of digital elevation models used. So we have used even 5-meter digital elevation model to 20-meter digital elevation model. We have calculated the accuracy by which we can arrive at this one. Okay, so the relative relief, the lineament, density of drainage. These are some of the factors: geomorphology, the land use, land cover, the lithology. So based on this, we have made the landslide susceptibility map. You can see the areas that are highly susceptible for landslides. And I should tell that when we have superimposed this with the archive data of landslides that has happened in Wayanad, we found it almost tallies for 70% of the area precise. Okay, so rainfall is one of the very triggering factor, and we have found that the rainfall which can exceed at a time 20 centimeters rainfall within a matter of 2 days can cause in very typical slopes exceeding 20 degrees. It can cause landslides. So this is what we have found. You can see the contours, 10-meter contours along Kavalapara, where devastating landslide happening. This is before landslide, how the Kavalapara looks like. This is Wayanad. you have seen that 45 lives have been taken away 2 years back. So these are the two locations where it did not slide. The entire area slid down, excepting these two areas. You can see the how it has effectively diverted the this slide along this and along this because of its steepness. You can see here we could steep it here it is not steep. You can see that steepness. So the flow steepness. So this is how we prepared even 2 meters. Very steeply sloping top from where, because of certain disturbance that has happened in the land use and the terrain. They have modified the terrain for the monoculture practice of rubber. And from here, it is very, you see more than 45-degree slope, this region. You can see the value you can see the degree. Okay, that means 100% slope. Okay, so you should understand the difference between degree and percentage. Okay, so anyway, it's of academic interest. So what I want to tell you is that here it is very steep, and along this steeply sloping surface, when the rainfall soaked the entire disturbed soil surface, it has gushed out. It could not stand with the torrential rain that has happened. Okay, so after saturating this layer, it slid down. So this is the area in which you can see we have conducted several studies using lidar, okay, lidar techniques by which we have measured how much of debris has been removed. This is the lidar points that we have generated. You can see a satellite image where only this area and this area has been spared. The entire area has become a wasted land due to the landslides. So here, Pettibudi recently in Pettibudi also in the Munnar happened. You can see the location, how you see where it has happened. This is before the Pettibudi incident, and then you can see after the Pettibudi. I have shown the previous slide. You can see this is the location. This is the location where you see this. The other all these layers, buckets of the labels are known as layers. They are all completely devastated. That is how it is. Okay, so you can see the slope. Actually, we have a observatory here. National Center for Earth Science Studies has got a cloud physics observatory here, and here you can see there's a huge hill over which slopes down. This is the area where the Pettibudi incident happened. The sliding happened like this. So this is what how it slides down. If the flow direction is also plotted. Okay, so this is what I want to talk about. So this is to start with, I have told that land degradation can accelerate, and in case of many landslides that has happened, devastating landslides that has happened in the recent times. See, there are two things. One is that there is a natural cause for landslides, but when the human disturbance happens, it easily makes soil susceptible for more water to get accumulated there. And when the soil gets saturated, the loose soil gushes out along with the soil because of the overburden. The other things are also taken away along the course of its flow down. So that is how in majority of the area you see this in Pilakavu, many places. You can see the houses damaged, the life taken away by this. See that at least we should have a good practice of land use to be followed. At least we should not be responsible for triggering the landslide in many of the vulnerable areas. So, the vulnerable areas can be identified because we have prepared landslide zonation map for the entire Kerala, and it is available on the website. So geologists can help people who are likely to suffer in future from this kind of hazardous the disasters, by properly adopting and mitigating uh, areas that are vulnerable to landslides. Thank you very much. If you have any questions, you can ask me.
Thank you very much, sir, for the wonderful lecture. It was very informative. Now we'll move on to question and answer section. If you have any doubts, type your questions in the chat box or unmute yourself and ask.
Thank you, Dr. K Ramachandran. May I
Thank you
audible?
very much. Yeah, I am audible. Yeah, please.
I'm asking a simple question.
Yeah.
So, when you're comparing India and China, the
Okay.
lithology of China and India, but Chinese land lithology is very softer one, I think so. But they are constructing various infrastructure on the mountainous area. That means the tunnels or the railways or various type of infrastructure projects like that. But there is not much report coming as landslide there when comparing to our Kerala or in Assam area
Yeah.
or even Kashmir area. What's the technology they are using there for strengthening the land?
I don't know whether it is right to tell that they don't have landslides. They have plenty of landslides. Okay, you can see here. See this. I don't know whether it is. Can you see this? Can you see the slide?
No.
No, sir.
Okay. I'll just show. See.
Here there is no problem. We can see, sir.
You can see?
Yes,
Yeah,
sir, we
yeah,
can see it
but
now.
you should be able to see that.
Here there is no problem. We can see it.
Yeah. Yeah. Can you see this?
Yes, sir, it is visible.
Yeah. So you can see that it is not very true that they have also sorry. See. They also have. You see this areas where they have plenty of landslides in one part of the sorry. The mountainous regions of China is also facing a lot of problems. It is not that they don't have. Okay, but let me tell that having said that, the proper engineering aspects has to go into it when you see a land which is vulnerable for such landslides or even earthquake. The Japanese making earthquake resilient buildings. How they make that? So there are a lot of engineering goes into it. Okay, so that is why you can see the very heavy landslides. You see, this is happened in China. So coming back to, shall I stop the presentation part? Can you see me?
Okay, sir.
Yeah. So see any area which has got a slope and overburden, rich in soil that can get soaked when a snow melt or rainfall happens. Definitely there can be slides. But what we were talking about is slide that was accelerated due to the human activities. Probably in China there must be having a land use practice in those areas, or they should be using the right kind of technology, engineering technology, to have their built up state. This is what I feel. Somebody is,
Can you hear me?
yeah, please.
Yeah, in this Kudiran, our tunnel is, we are waiting for that tunnel. Is there any geographical problem near this Kudiran?
I think there are many things that has to be verified. We have not actually gone into an environmental impact assessment of that Kudiran, tunnel. So you mean the one which has been proposed, is it not? By the Kerala government, is it not?
Yes, sir. Yes.
Yeah. So actually, I have not seen the traverse through which that particular tunnel is going to be built. Right now I am not able to comment. But what I understand is that geological study as well as the environmental impact assessment has to be done for that. So until details are available about that, there are places where tunnels have been made. We know the DST project, which is happening in Tamil Nadu, Kambam area. Okay, we are going to have 2 kilometer long tunnel there built. Okay, so very deep tunnel. So for the experimental physics lab. Okay, so we have many tunnels around the globe, right? We have to see whether the massiveness of the rock will have easiness to make a tunnel there. That's it. Okay.
Okay, sir. Thank you.
But regarding the Kudiran area, I don't know whether the geologists, geological survey have conducted any testing or a survey or investigation.
Davis, I have my own assessment about that. I am not telling it openly because it is an issue which is pending with the government. Okay.
Now the main, I don't know, sir, you might have already noticed that, from the Vadakkanjeri, we already installed one seismic center. Already when we are associated, I also associated when I was in NCESS, that time there was a report from Vadakkanjeri to Adirapalli area. There is a big lineament is passing through the Kudiran area, adjacent area. Am I right or not? That may be the reason for this landslide area that is happening now.
Yeah, that is right. But you have small and big lineaments which are. We don't find many neotectonic lineaments along those regions. That is what I understand. The one which you have mentioned is definitely yes. Yeah, there is a lineament, but whether it is not an active one. That is what. Anyway, I don't want to go into the details of Kudiran because it will turn out to be little political and things like that. So that is why I'm not opening up.
Okay, no problem, sir. Leave it.
Thank you, sir. There is one more
good
question.
morning, sir.
Yeah, please.
Can I ask?
Yeah, please.
Yeah, sir. Actually, you have said that Western Ghats extends from Dhule, from Maharashtra up to Kanyakumari. So it's a very long stretch.
Yeah.
And we are seeing most of the landslides are occurring in the Kerala side only, but not in the Karnataka side or Maharashtra side. So what can be the possible reasons for that?
Okay. It is not very true that it is happening only along Kerala coast. It is Malaysia. Many places it is happening. But in the number of landslides that has happened becomes fatal. Only when it becomes fatal, it is getting reported. Okay, one thing.
Okay.
Second thing is about our density of population. Occupying the higher slopes by our people. Okay, our cultivation practice. All these things matters here. Okay, when you move towards northern side, you can see you yourself can assess what I have to do. So that is the reason.
So it has nothing to do with the density of lineaments or anything like that.
Yeah, lineament is one factor. See, I have shown that the PAS methodology in which lineament is one factor. The nearness to lineament is an important factor. It has been given weightage of 1 in that.
Okay, because in Kerala side we have seen that many crisscrossing lineaments are there, like northwest southeast and northeast southwest. But whereas when we come towards the northern side, it is comparatively less.
Is it so? If you see the satellite images today, I see it is only a scalability of mapping problem. I think you have lineaments in the northern side as well, but we have mapped a lot in Kerala.
Okay. Thanks.
Sir, there is one more question from
Yeah.
Aisha Rafi. If the landslide
Okay.
continue to happen, what
What
do
do
you
you
think?
think will
What
be
do
the
you
future
think
of
will be
land?
the future of the land where landslides occur?
Okay. See, if landslide happened in areas where landslide happened, probably we have to practice a new kind of land use, uh, perception. We should move with new perception of land use. Okay, we can definitely, we cannot make the land remain as a wasteland. Okay, we should. One second. Now, ah, ah. Open in the. Okay, 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 okay. Thank you. Okay, it is from Kufas. Anyway, so a call from Kufas. I want to tell you that we can have adaptation and mitigation strategies for areas that are vulnerable for landslides. See, we should practice mitigation may be a very costly affair, but adaptation is an easier process. Okay, let us adapt by realizing that these areas are vulnerable. Let us have a different kind of a land use practice. Let us make way for the nature not to tamper with our life by adopting appropriate distance from that to have our houses constructed and all that. So this is how probably we should tackle this. Okay.
Thank you, sir.
Yeah. Yeah.
If there is any other questions? Okay, if there is no further questions, that conclude our Q&A section.
For the information for the participants, I don't know whether you people might have noticed or not. We have a lecture series for days, now 3 days over. The first day lecture series was from the air, we studied something, the geology. The second day, it was under the sea. Now third day today, landslide on the surface of the earth. Then tomorrow, our lecture series ending with a topic that is underground. So these are the 4 zones of geology. We selected the topic for covering vast area of the earth. So this is for the information for you. If you have any doubt regarding today landslide, very interesting one, Pettimudi. Anything if you want, we can ask. And Dr. K Ramachandran is not only expert for the landslide, he is very expert for the coastal geomorphology or coastal engineering and even or earth, any branches of earth science. So without any hesitation, I know Dr. Ramachandran very well. We are also associating with the Center for Earth Science, and he is a former our college mate from the University of Kochi on Science and Technology. I know his caliber. Without any hesitation, all participants can deliver any doubts regarding any branches of science. I mean, especially geoscience. Please.
When the Javis, when the classes are on, I will come one day and meet your students.
Okay, you are welcome at any time. After COVID-19 is over, I will invite you for a detailed program. I am very happy to proudly announce or proudly inform you that, our second batch, we are placed in the first and second rank in our college from the Calicut University.
Wonderful. Wonderful. In fact, when I and
We are always contacting various resource personnel from various scientific community and interacting with them for giving a good opportunity for our students also. This is our motivation for our students.
okay.
And I request Dr. K Ramachandran, please my convey regards to Dr. C.M. Harish. Okay?
Sure. Okay. Thank you. Thank you then. We will meet again. Okay, fine.
Thank you very much, sir. Tomorrow will be the final section of this lecture series, Managed Aquifer Recharge, by Dr. C.P. Priju, Scientist, Center for Water Resource and Management, Calicut. The lecture will start at 9:30 a.m. sharp, and everyone please join before 15 minutes, and the joining link will be shared to you through emails. Now, I invite Arul Tejas, second year BSc Geology student, for delivering vote of thanks.
Am I audible?
Yeah.
Yes, Arul.
Good morning, everyone. Respected Executive Director, Reverend Dr. David Kenyaran, Principal Dr. Pio Jensen, Vice Principal Dr. Matthew Paul Cookan, our beloved HOD, Professor David KJ, our honored guest, Dr. K Ramachandran, faculty members, and dear participants. On behalf of Sahardaya College of Advanced Studies, I would like to express my gratitude to our chief guest, Dr. K Ramachandran, who spared his time for the webinar to help us explore more about environmental degradation leading to landslides in Western Ghats. Thank you, sir, for the interesting and enlightening class. Now, I extend my sincere thanks to Professor Dr. S. Srikumar, Director, IRDC, Palakkad, for sparing his valuable time from his busy schedule to felicitate this webinar. I would like to express our profound gratitude to our Principal, Dr. Pio Jensen, Vice Principal, Dr. Matthew Paul Cookan, Department HOD, Professor David KJ, for providing us this wonderful webinar series. I would like to express my hearty thanks to our Professor David KJ for the guidance. I'm happy to express my gratitude to the faculty of Department of Geology, who have also made this webinar a great success. Last but not the least, a great appreciation and thanks to all the participants who chose to be live with us and attend the webinar with an inquiring mind and made it a successful event. Once again, I thank you all for your presence and participation. Thank you.
Thank you very much. Okay, thank you.
Okay, thank you.
Once again, thank you all for attending Day 3 lecture. Hope it will help you in your future career path. Thank you all.